Very good at triangle. So basically your whole objective is to read these words and try to draw the picture. So, here we go, watch. Where is this? Why is your trig worksheet out? Everybody have this out. Even if you didn't do it, I'm gonna help you do it right now then. What? Yeah. So here we go, a sledding run, which, if it's okay if you didn't get that because of the vocabulary, that's this guy right here. A sledding run would be the slant down the hill that you were sledding down. That's 300 yards, okay? Then, so there's my yards. Then it says with a vertical drop. So where are you gonna put the vertical drop? Just look at the triangle. The vertical leg would be the straight up leg then. Then it says, what is the angle of depression? Oh, class, let's talk about that. Yeah, which one is it? The angle of depression is created from the top straight out. But we know the angle of depression is what? Congruent to the
Angle
of elevation. So that's really this angle right there. Would you guys stop looking at the little kids walking in the hallway? Okay. So if I find the angle of elevation, I can find the angle of depression. So therefore, all I have to do is go like this. Hey, if this is my, which one do I want? I think this is the laser. There you go. If that's my angle, where is this from the angle?
opposite
And this is the? What does that trigger in trigonometry?
sine.
Very good. Everybody should say that all at the same time. It triggers the?
Sine.
Yep. So how do I set this up?
Sine. What?
Sine?
The sine inverse.
Why do I do inverse?
Because of
Angle. Every time. There you go. Now, this is where you can take out your calculators. You can do all this. I won't, but there you go. That's set up for number one. Okay? Reading these word problems and doing these. By the way, you have to have this scanned in and turned in today. Okay? So if you have this done, you're set. You can take the picture, turn it in the classroom today, and you'll get full credit for it. If not, you can do it right now, finish it up tonight, and you'll still get on-time credit. Okay? All right, that's one. All right, number two. Here we go. Just read the problem. Let's do this one now, okay? A doctor is using a treadmill to assess the strength of a patient's heart, which is pretty true, actually. We should do that. I'll bring one in. Not a treadmill. He sets the long treadmill at an incline of 10 degrees. So watch this. I have the ground. I have a treadmill going up like that. Where do I put the 10?
elevation.
There you go. Angle of elevation. Then we drop this straight down because we know these are always right triangle problems. What else? What other information do they give you? He sets the...
48.
Oh, yeah, it's good. Where do I put the 48?
Hypotenuse.
Yeah, it's at the height of the hypotenuse. This is what the homework is all about. Where do you put it? If it's the length of the treadmill, think about that. Where would I put it? Right there. Because think about a treadmill. If they said but if he said, they would specify, they would have said the treadmill is 10 feet above the ground. If they said that, that's where you would put like that part over here. So notice you had a debate, do I put it here or do I put it here? Every single time, okay? But now here's how you know you do it right. Because look at the next question. What does it say? How high is the end of the treadmill raised? What does that mean? It means you know that you were solving for the vertical height. So you'll know right away, did you put the numbers in the right spot, okay? Now, this is when you use the trig equation. Look how great this is, guys. Example number one is an inverse example. Example number two is a solving example. Now, once again, let's put all the pieces together. So I have opposite and hypotenuse, so I'm going to do it real quick for you. Sine of 10 is opposite over 48. Look how great those warm-ups were on the board for us. I know this now, that when opposite and hypotenuse, it's a relationship of the sign, right? When do I know when to solve it? When do I know when to give a fraction? People have asked that, which is awesome. The angle of elevation of the sun with a 12.5 meter tall telephone pole casts a what? Yeah, it casts an 18 meter long shadow. What would this look like? How do you draw it? Let's take a moment. What would I put where? Good, vertical line. What does that represent? The what? The telephone pole, right? Then let's draw the sun. The sun is casting a shadow. So, yes. Oh, yes. Well, basically, yeah. Good. Someone said horizontal. That's yes. It's making a horizontal dimension. Perfect, okay? Again, that's 90. We hope all telephone poles are 90. All right. Where do I put the numbers now? Telephone pole says it's 18-meter long shadow. Where would I put the 18-meter long shadow? Very good, right there, right? That's the beauty of that one. That thing is 18. Then what does it say?
Find the angle of elevation.
Yeah, where's the 12.5? That's the vertical. It says find the angle of elevation. Where do I put the theta? Bottom right. Okay, now you have to use all your lessons of trig and say, all right, how do I find that theta? What's the relationship? It triggers only one. Just look at the relationship formed between all three parts. It's the adjacent and the opposite. What trig function always has those two? Nice. Inverse or regular tan? Inverse. How do I always, you're trying to find an angle. Could not have said it better. What do I put? No, order is everything. All right? It's like the tattoo on the forehead I would get for you guys, which now that I'm bald, it would really stick out. What would it say? Or what would it look like?
18 over 12.
18 over 12 or 12 over 18? It's 12.5 over 18. Here's why. Good questions. Watch. You're here. So opposite is this, and that's where you put opposite.
Isn't it adjacent over opposite?
No, it's toa. Soka toa. Good, it's opposite over adjacent. Good, look how we defined it. In our definitions, we said the tangent is the opposite over the adjacent.
What's the
Let's just draw it, right? Half the battle is drawing this. So here we go. A person whose eyes are 5 feet above the ground. Let's talk about what that would mean. Let's draw our little person. That would be our 5 feet. The eyes would be right there then. Is standing on the runway of an airport 100 feet from the control tower. So let's draw a horizontal. You are 100 feet away from that control tower. Notice I'm just building this, right? The person observes an air traffic controller at the window of the 134-foot tower. So now we have the tower here. That's 132 feet. So I put all that together. Yeah, what is the angle of elevation? Oh, what in the world are they asking for?
Or the eye level to the thing. Yeah.
Right, so we draw a horizontal line with the eye level because we want to look, what is he looking up at that from? So everyone who did that bottom, nice, but that was just, oh, I did not want to do that. Oh, yes, you got to love undo. Basically just, hey, take away that bottom one and now really just write in, oh, that's the 100. So the 5 feet is just a what?
It's just the altitude.
It's kind of a trick, but watch how careful you have to be.
Subtract 132.
Right, because class 132 is the total distance right there, right?
132 minus 5.
Right, what's 132 minus 5?
127.
That's what that leg of the triangle actually is then, because they're just really messing with the orientation of the whole thing. You're trying to find the angle of elevation, so class, guess what? You are trying to find that angle right there. Okay, which one is it? Sine, cos, or tan? Good, you're getting very good at this, I hope. And it's inverse, I kind of did that. I should not have probably done that. 127 over 100. Verify that you understand why I just wrote tan inverse of 127 over 100. Because 127 is what from the angle of elevation? And 100 is the?
Adjacent.
I'm just, the more you speak it, and like when I had you write the sentences, the more you do that, the more you get to learn it. The more you're okay, got it. Okay? There you go. Oh, we should do number 7. I love golfing. Terrible golfer, but I love it. A golfer standing at the tee, looking up on the green on a hill. Ooh, that means you have to elevate your ball. So people like me who cannot hit my ball up, this is a challenge. And the whole premise in golf is to hit the ball up. So now you really get how much I suck at golf. The tee is 36 yards lower than the green, and the angle, oh, they love to mess with you. Notice how these problems are getting a little bit more intense, right? Let's draw it. Right, let's just go through it. Notice how my opening drawing, I manipulated my original drawing. And please do that. So here we go. A golfer is standing at the tee. So let's put this as the tee. You got a guy standing right there, looking up on the green on a hill. So at least I know he is looking up. I'm going to go dotted for just the fact I'm looking up, right? That's me standing there looking up, right? If the tee is 36 yards lower than the green, so I could draw this then, because they just said if I'm here at the green, that's 36. And an angle of elevation from the T-hole is 12 degrees. Where do I put the 12?
And the other
Wait,
Yeah, so I'd go like that. I'd probably connect these, and my guess is I'm thinking 12 is right there. Find the distance from the T to the hole. Oh, look how they naturally. They're asking for that. Or, yeah, or did I go too fast? I might have done way too fast. Let's look at this again, okay? All right, let's talk about it. What do they want? Read this oh so carefully. Find the distance from the T to the hole.
Oh, maybe wouldn't it be the hypotenuse?
Yeah, do you think it's the hypotenuse, or do you think it's the horizontal?
Well, because
Hypotenuse.
it does take ground
Hit it
distance.
that distance.
Right, but and it literally wanted the T to the hole.
But it didn't.
And is the hole above, or is the hole level with me?
Above.
So what do they want?
It's the
Hypotenuse.
hypotenuse.
Yes, that is so hard.
I was like,
That
why
is
do you
not
think-
easy, man. And gals. Good, I'm glad we're doing this one, because here's why. I know what this is gonna trigger.
Sine.
Yes, and where's the x going to be?
One bottom.
Very good. Everybody, let's write the trig function, okay? So again, I'm trying to find this x right here. The sine of 12 equals 36 over x, and it's so important you put that exact order. Okay, this is a great example because x is now in the denominator. How do I solve for that x?
Flip the sign of the.
Flip it.
36 over same 12.
Okay.
One more time.
Hey, just so you know, we're recording this, and this is gonna be on YouTube, and flipping is just our trick. What are we truly doing?
178.9.
Cross multiplying and isolating x, but we know that when we do that process, what do we get? X equals the
36
over the,
side.
yeah, so we're taking this giant shortcut of just interchanging, right? We're understanding that I'm just taking this and putting it there and vice versa, okay? But really, there's a mathematical reason why that works. Hey, take it home from here, class, okay? You guys got it.